Because today we are doing properties of log. So the first example that we have about properties of logs, and we are applying every property that we have learned before. Especially we learn about the logarithm rules. We are applying every logarithm rule to these equations. So the first one that we have is the log. We have the log. Uh, we have the log of b, and then the exponent is a 5, it's a n, and it's a m. And what we would have to apply here is the product rule. The product rule help us to expand this logarithmic expression in three different sections. So the first one that will be the log of b to the 5 plus the log of b to the n plus the log of b to the n. And that will be the answer. And that is the product rule. You can see that will be where we have applied the product rule. So you finish your notes, and we go to question number 2. As our second, that will be the first example. Let's put 1. Example 2, we have the log. We have the log of 2 of 9x. And we have to apply also the product rule. How we expand, remember when the exponents are being multiplied, we add the logs. When the exponents are being divided, we subtract them. So in this second example, also the exponents are being multiplied, so 9 times x. So that will be equal to the log 2 of 9 plus the log 2 of x. And again, we have used here this x. And do a better x. And we have applied again the product rule. Any questions so far? Sir. Okay. But let's go to our third example. Example number 3 for this assignment. We have the natural law of 3 over 7. If that is equal, and now you can see we have to apply the quotient rule because these two numbers have been divided. So we have the natural law of 3 minus the natural law of 7. And that will be the quotient rule. The quotient. And will be examples that we'll be using more than one rule. We have also the following one. Example number 4. We have the log. We have the log 3, and you have a 5 over x. 5 over x. How we work this one?
It'd be log 3 to the fifth power minus log.
Exactly, will be the log 3 to the fifth power minus no the log 3 of x. Excellent. And that is also the quotient rule. That will be the quotient rule. Any questions so far?
That's it.
Let me erase to be able to, because I'm losing board space. Let's do number 5. I will let you take your notes. And I'm recording this assignment. Then you can go back and you can review again and forward and check what we are doing today. Be sure that we are recording. Yeah. So the next step, the next question that we have, example number 5 for your assignment today, example number 5, we have the log no, of 1 over 5x, and that is a little different than the other one because the denominator is raised to a power. Close the door. I forgot to close the door. Yes. First of all, let's try to expand that. We need to use the quotient. We need to use the quotient rule. But let's first of all rewrite this because remember when we put a number that is raised to exponent under 1, that means that is a negative exponent. That we can be rewrite as the log, and because don't have a number in the log, you see there's no base, we can assume every time that you don't have a base, the base that you should put here is 10. That is the default base. Again, if you don't have a base in the problem, you can assume it's a base 10, and that will be of 5 to the negative x. That's the reason it's under 1. And then what we need to do is that we need to use the power rule. When you use the power rule, you have negative x, no, and times the natural log of base 10 to the fifth power. No, and that will be the answer. And that is the power rule. Let's go to the next example. Let's go to example number 6. In example number 6, you have the log base 3 of x to the 6. So we know that when you have an exponent that is raised to an exponent, we can use the power rule to simplify this logarithm. So we have the log base 3 will be, according to the power rule, this 6 that is the exponent of the exponent go to the front. That you have a 6, no, and you can put in parentheses you want log base 3 to the x. That will be the answer. And again, we have used the power rule to simplify this expression. So any questions about that?
No, sir.
Okay, so let's go to number 7. Number 7. So in number 7, you have the natural, number 7. You have the natural law. Let me put a little down to have a space. You have the natural law, and in the exponent, you have a to the 9 power. You have a to the 9 power is multiplied to a b to the 6 power and r over a c to the 7 power. So let's expand that using, first of all, we're using the quotient rule. So and the reason I want to use the quotient rule is because I want to take this c to the 7 out of the denominator. So you have a natural law, and we have here our exponent a to the 9 times b to the 6 minus, because remember when it's a division, no, we use the quotient rule, we subtract, minus, no, the natural law of c to the 7. So now we went to the first expansion of this logarithmic expression, and that we have used was the quotient. We use the quotient rule. Our second step, we have to apply now the product rule, because we still have a composite exponent. You have a to the 9, and they multiply to b to the 6. Is to deal with them, we have to use now the product rule. And it will be the natural law of a to the 9 plus the natural law of b to the 6, and we put the last part, no, that we did before, the natural law of c to the 7. And that is the product rule. We will use the product rule. And then we use the power rule to simplify this expression, because we have an exponent that rises to another exponent. Every time that you have an exponent that is rise to another exponent, you can use the power rule to simplify. You can move the second exponential number or expression to the front of the natural law of the law. So that will be, we'll put the 9 in the front, will be a 9. And you can put in parentheses or not, it's up to you. Natural law of A plus 6, the natural law of B, minus 7, the natural law of C. And that is the power rule. As you can see, we apply 3 of the rules that we know in one of the problems to be able to simplify this expression. Is there any questions about number 7?
Yes, sir.
No? Then let's go to number 8. I need to erase that in order to be able to put 8. Then let's go to example in 8. No? Number 8, you have the log of 8, and then in parentheses, you have here x to the second power, y to the third power. So again, I will have to use, because are being multiplied one to another, I will use the product rule. No, and that will be the log, no, 8, the log 8 of x to the second power, no, plus the log 8 of y to the third power. And then after that, that is the product rule, the product rule, the product rule. That is the example number 8. And then I will use the power rule to move this exponent of exponents to the front. So the next one will be, I will need to move these 2 to the front, and these 3 also to the front. So we have 2, no, the log of 8 to the x plus you have 3, no, you have a 3, no, the log of a base 8 to the y, and that will be the power rule. And we have a lot of examples because we need to be familiar to them. Because in the exam, that what you have to do, you go back and forth. They will give you a log, and you have to expand the log using the rules. And then they will give you an expanded version, and you have to go back and put in one single logarithm. Any questions so far?
Yes, sir.
Okay. Let's do the example number 9. Example 9. In example 9, you have the log. You have the log, no, a, base a, and the exponent is the 4 root of x. How we simplify this? How we simplify this logarithmic expression? Well, first of all, let's change the exponent from a radical form to exponential form. If we want to change the exponent from a radical to exponential, no, you have the log a. We know that the exponent of the radicand, and the radicand is the term that is under the radical sign. In this case, it's an x. What would be the exponent of this x? The exponent of x.
1.
1, because when you don't have when they don't give you a leading coefficient, or they don't give you exponent, you can put 1 as a default. So, and we can say, we always say that when we put this in exponential, always the the index, that will be 4, the 4 root going as a denominator, and the exponent of the radicand is numerator. So that will be x, rise to the 1/4. So what we're doing next? What we're doing next?
Quotient form.
Why the quotient? Do you see something? Because that is exponent.
Oh,
See, the exponent is 1/4.
power rule.
Power rule, exactly, because we need to simplify, and using the power rule, we move the 1/4 to the front. So you have a 1/4 times the log of 8 of x, and that will be the final answer. Any questions about example 9? Let's go to example 10 and 11. I will have to erase that. I will give you a minute. Did you copy and take your notes? And we're going to the example. Let me erase that, and we go to example 10 and 11, and probably 12 too, if the board is enough large to put all together. Then let's go to the example 10. In example 10, you have example 10. You have the log 8, and then you have here 5x over y. And what we're doing there? I will first of all apply the quotient rule. Because if we apply the quotient rule, we have the log of 8, and when you keep your 5x there, we're doing later with the product rule, minus the log 8 of y. And we have used the quotient rule, first of all. The quotient rule. And then I will use the power rule to simplify the first term, or the first logarithmic expression. So this I will do, that will be equal to the log 8 of 5 plus the log 8 of x minus the log 8 of y. And we are using the product rule. There's any other thing I can do to these equations? I can simplify them more. No, that is as far as I can go. There's nothing else to simplify. Any questions about question 10?
No, sir.
Then let's go to 11. Question 11. In question 11, you have, they are given, we are going backwards. They're given the 4 log b, of x plus the 4 log b of y. And we need to put this back in one expression. I will give you 3 minutes. You can try to do it. How you can reverse. You have to reverse two properties, there are 2 rules. What you reverse first?
The power rule.
Excellent. Outstanding. Exactly. I will reverse the power rule. So and that will be the log b, no, of x to the 4th power plus the log b of y to the 4th power. This we reverse the power rule. We reverse the power rule. So now what will be your second step? What else you can reverse then?
The product rule.
Exactly. Excellent. I will reverse the product rule. I will combine these two logs. There will be a log, no, b, and then my exponent will be a x to the 4th power multiplied to a y to the 4th power. And I reverse the product rule. And that is the answer. It's as far as you can go. You have all in one single logarithmic expression. Any questions about question number 11?
Sorry.
No? So let me erase that. We'll give everybody a minute. They can copy your notes, and then we'll go to 11 and 12. And we're going fast. We can finish the whole thing today. Let's erase that and let's try to do 12 and 13 if the space permit. Have enough space in the board to do it. As we go over and over, we are using more and more combination of rules. So we're in question number 12, no?
Yes, sir.
Let me pass my page. In question number 12, we have again another. We have 1/3 log, and they don't give you a base. Because I don't have a base here, I will put base 10. Base 10 of x plus 1/2 the log 10 of y. I will give you 2 minutes to reverse, to put this expression in one single logarithmic expression. Let's try to do this by ourselves, and then we'll continue. You have 5 minutes to do it. We have an answer?
Yes, sir.
What will be the answer?
Log base two of, the third root of x, to the square root of y.
Let's do together. Very good. Let's do together. So it's the first step I need to do that is I need to reverse what?
The power rule.
The power rule. And reversing the power rule, I have the log 10, no, of x to the 1/3. And then plus I have the log 10, no, of y to the 1/2. So I have reversed it. First of all, reverse, no, the power rule. Now I can also reverse the product rule. You agree with that?
Yeah.
So let's put all together in one compound. So you have a log 10, no, of x to the 1/3 times, no, y to the 1/2. And doing that, I have reversed also the product rule. And I can go one step forward. I can put these exponents as a radicals, no? So I will have log 10, no, of the cubic root of x times the square root of y. And that will be my final answer. I cannot reduce this to nothing else. So that is the example number 12. Yeah, number 12. Let's try to do example 13 if the space permits. I will erase that. I will give you a minute. You can copy your notes because the note will be down to the bottom. Sometimes hard to write there. Okay, let's erase all this stuff. And let's go to example 13. As example 13, I have a 5 log of b to the x, no, minus 5 log of b to the y. So what will be the first thing that we're doing here? What we have to reverse?
Power rule.
Do you see the negative in front of the two logs?
Yeah.
So it's
The quotient rule.
the quotient rule. Very good, because we are subtracting. This I will start reversing no, first of all, we have to reverse the power rule. No, and we have here the log, no, the base b, no, of 5 to the x, no, and there will be a minus the log b of y to the 6. So we have reversed the power rule there. Reverse power rule. And now, after reverse the power rule, I can reverse the quotient rule. So I can put all in one log. So you have a log b, no? And in the numerator, you have a 5 to the x power over y to the x power. and we have reversed the quotient rule, the quotient rule. There's any other thing we can do there?
Yes, sir.
No? I guess we have done all that we can do. So that is example number 13. Let's go to example number 14 as you copy your notes.
We're out of time.
We are out of time?
6 minutes over.
Wow, well, I will see you then Monday. Okay? I will continue recording this video, but I will see you Monday.
See you Monday.
This video will be there for the assignment of today. You guys are responsible to work everything until properties of logarithms, including the quizzes.
Yes, sir.
Monday we'll review the last one, and then we'll start reviewing for the exam.
Yes, sir.
Have a wonderful weekend.
Yes, sir.
Forget to go Sunday to church. Let's do example number 14. Example number 14, you have the log of, and there's no a base, as I will assume every time that you don't have a base, you can put the base 10 as a default base. And then the exponent is the square root of a to the 4th power and b to the -5. Because my first step is I will convert this exponent from radical and will go to exponential. So I have a log 10, and I will do individually, the square root of a to the 4 plus, I will apply first of all, let's apply first of all the product rule to broken in two different radical expressions, and the log 10 of the square root of b to the -5. Then what we did here, we reverse we apply, not reverse, we apply the product rule. Now we can convert these radical exponents in exponential form. So you have a log 10 and a to the 4. Remember, there is a square root here. We never put the 2, but there is a 2 there. And we always said when we convert from radical to exponential, the exponent to whom the radicand a is rise up, this exponent is the numerator, and the index always will be the denominator. That will be equal to a 4/2, the exponent, plus the log of 10, and then you have a b, and the exponent would be a -5/2. So we have convert first of all, we apply the power rule, and then we convert the exponent from radical to exponential. That was the second step. Now I can, after do that, what I can do is I can use even the I can use the power rule because this is an exponent of exponents, a raised to the power of 4 over 2. But I will simplify also, no? Because a to 4 over 2 is, let's rewrite that to be the log 10, no, of a. 4 divided by 2 is a 2, be a to the second power. And the other one keep the same, no? It will be the log 10 of b to the negative 5 over 2. Now, I will use the power rule to move these exponents of the exponent to the front of the logarithmic expression. We use the power rule. And that will be, these two go to the front. There will be a 2 log 10 of a plus negative 5 over 2, no, log 10 of b. And that will be the final answer for question number 14. As you can see, we have done or applied three. First of all, we applied the power rule. Then next, what we did is convert the exponents from radical to exponential form. And then finally, we use the power rule to simplify the expression. Let me erase and let's go to question or the example 15 that we have. Let me erase that. And I try to put in this video every scenario that you have in your homework. That you will be able to go and do your homework in person with no problems. And remember, no, what I always said, no, all the assignments, all the assignments and all the quizzes are open book, so you can use your notes to solve your quizzes and your assignments. And you know that is better than use AI. I see a lot of students use AI to do the homework and the assignment. They're cheating to themselves and hurting themselves because when you have to do the test, you cannot use AI. And you don't, math is, you need to, and try to explain. No, I don't only tell you what are the steps, but I explain to you why I'm doing everything, because the first thing that you have to learn in math is and anything is the why and the when, and the how to do it, you will get it practicing. That is the reason we give it to you homework, and you can go and you can practice this homework. And as you practice the homework, you get skills about how to solve logarithmic expression. So let's do question number 15, no, example 15 for your assignment. So you have the log, base 6, and the exponent is the cubic root of x. That is your exponent. So the first thing I will do is I will convert my exponent from radical to exponential. So I have the log 6. And remember, when x don't have a coefficient or don't have an exponent, you can write the default one, that is 1. 1 is the default leading coefficient and the default exponent for any polynomial. If they don't have 1, it will be 1. The only exception is when you try to, the constant, when you have a constant in a linear equation, the constant have an exponent of 0. But let's keep moving, because I will change. We already said that when you go from radical to exponential, the index is also always the denominator, and the exponent of the radical is the numerator. So that will be equal to x to 1/3. No, and then my third step, I will use the power rule to move this 1/3 to the front. No, since I will use the power rule to, let me do it a different way because only that will be log 6 1/3. So what we do here, we convert the exponent from radical form to exponential is what we have done. And then my second step, I will use the power rule. So I will move the 1/3 to the front of the logarithmic expression. So I have 1/3 times the log b. Oh, I forgot the x, sorry, x to the 1/3. No, the x was there, and that will be log b, no, the log 6 of x. So with 1/3 times the log 6 of x, and what we have done, we use the power rule. Power rule. I will give you a minute, you do your notes. I always said, no, a note taker is a test maker. Because when you write notes, you are encrypting in your brain everything that you are writing. Remember when you was a little child and you have something like this, and you have the letter L like this, and then you have the letter M like this, and dot, and the letter N, no, also in dots, and the teacher told you have to trace over the dots, and you were using your pencil, no, and you were tracing over the dots, and you begin to learn how to write a L, and then how to write a M. And when you was doing that, you was encrypting in your mind the shape of a N and the shape of a M and the L. That is the same thing what you do when you write notes about what you are learning, because your brain is listening, but in the same time you are writing your notes, and that get attached together. So let's go to example 16. Let me change colors. Example 16. In example 16, no, we're in 17. Give me a second, guys. I jump a page. Okay, example 16. Example 16, again, they are going backwards. Let me see. We did this already. We already did, probably I skip it and we did it, but let's go to example 16. You have the log. Again, if they don't give you a base, you can assume that it's base 10. That is the default base for any logarithmic expression. And the exponent is a polynomial. You have a x squared minus 64, no, minus, no, the minus 2 log of x plus 8. So my first step is to cancel, to reverse the power rule. The first one don't have a power rule applied, but the second term, we apply the power rule. So if we do that, would be the log, no, base 10, is 10, no, of x squared minus 64, and that is a polynomial, no, and then I will use reverse the power rule in the second term. So it will be minus the log 10, no, of x plus 8 squared. Because now that we have revert, let me do a better R. We have revert the power rule. Let's try to revert also the quotient rule. No, and if I do, I will write all these logarithmic expression in one single expression. So you have a log base 10, and then my numerator will be x. Let me put in one parenthesis x squared minus 64, and my denominator is x plus 8 squared. So that is my logarithmic expression that was expanded, and I'll bring it back to one single logarithmic term. But I don't finish yet, because you can recognize what kind of logarithm polynomial is the numerator. And I heard, yes, of course, it's a difference of two squares. So we are applying a factorization to this problem. So that is equal to, say, the log base 10, and I will simplify the logarithmic expression in the numerator, no, because it's a different two squares. I put two parentheses. I put the square root of x squared is x, and the square root of 64 is 8. We know that the first is positive, the second is negative. And then in the numerator, then in the denominator, I have x plus 8 squared. That means I need to write twice this expression. No, x plus 8 times x plus 8. And when you do that, you can see that you have x plus 8 in the numerator. You have there, you have a x plus 8 in the numerator and 1 in the denominator. You can cancel that. So my final answer, no, will be the final answer will be the log base 10. And then in the numerator, I will have a x minus 8. And the denominator is x plus 8. And that will be my final answer for this example 16. I hope that you understand every step I'm doing, because you have similar problems or questions in your homework today, but also remember how we do in our quizzes and exams. For every 2 or 3 homeworks, we take questions to do a quiz. And then from all the quizzes or all the problems or questions of the quizzes, we pick 2 or 3 or 4 for each one of them, and we create an exam. So it's a big probability that you will see the same problem that you're doing in your homework. You will see this problem again in the quiz, and then you will see the same one in the exam. And because you have practiced so much and you know how to tackle each one of them, you have a great score in the exam. That is the reason practice makes things perfect. Math, to be able to know how to perform these equations, you need to practice. You cannot memorize, you cannot cram, because you can see most of the problems that we have here are different. So sometimes are not all the same. So let's go to example number 17. Example 17. And in example 17, they are giving you a logarithmic expression that have been expanded. Again, you have 5 log. Again, there is no base. I can assume it's base 10 because that is the default base. And then the exponent is a x. And then that is subtracted. No, it's added to 1/5, no, the log 10 of y. And that is subtracted from 3, no, log 10, no, and the exponent is a z. So we need to, first of all, we need to cancel, we need to revert the power rule. Do a better P, the power rule. That is the first one. So when I reverse the power rule, my new expression would be the log 10 of x to the 5th power, and then it will be plus, no, the log 10, no, of y to the 1/5 power, and then minus, no, the log of 10 again, no, the log of 2, and the exponent would be a z to the 3rd power. What we do next, after we be able to do all this work? Well, we need to put this together. You know, you can, if you want to, the second one convert in a, and we can do that, no? We have the log 10, no, of x to the 5th power. We can convert this expression, the second log, to a radical expression. Log 10, and the exponent will be the 5th root of y to the 1 power, no, minus the log 10 of z to the 3rd power. And now we can combine all together in one term. No, we need to do that. No, I cancel here, I revert the power rule, and then secondly, I revert, me to be consistent. I revert the product, and quotient rule. Because you have a plus and a minus, that means you have two terms in the numerator and you have one term in the denominator. So to put all together, we have the log, no, 10, no, of x to the 5 times the cubic root of y, no, and then there's over, no, the z to the 3rd power. And that will be the answer. That is the answer for this example number 17. So you can see we're trying to practice almost these different rules and different scenarios. In order when you are in your homework, you know what to do. So let's go to example number 19. And the assignment have, I guess, 25 questions. As I'm trying to cover, I don't cover the 25 because some of them are very repetitive, but I try to find the ones that are not repetitive in order you know what to do in every circumstance when you are doing your assignment. Let's go to this one. No, you have the log base 2, and the exponent is the square root of x, y to the 4th power. So let's first of all convert that from exponent radical to exponential, no? No, and when you do that, you have the log 2, no, of x to the 1/3 times no y. No, sorry, it's no 1/3. Has to be what kind of root is that? Hold on. Oh, it's a third root. Sorry. Let me do this again. No, it's the third root. It's the third root of x, y to the 4th power. That is your exponent. So now we change from radical to exponential. So it will be a log 2, and the first one will be a x to the 1/3 times y to the 4/3. Remember, always the exponent to whom the variable is raised as the numerator and the index is always the denominator. The first thing we did is we convert the exponent from, or the argument, we could call the argument or the exponent, argument or the exponent from radical to exponential form. Then my second step, I will apply the product rule over that. No, log 2 dv of x to the 1/3 plus log 2 of y to the 3/4. What I did is apply the product rule. Then I will use the power rule to move the exponent of the exponent to the front of the equation or the logarithm. Because I have 1/3, the log 2 of x, plus you have 3/4, the log of 2 of y. So we apply power rule. And that would be the final answer because there is nothing else we can do there right now. Question 17. So let's go to the next one. Let me erase that carefully. So that was question 19. Sorry, guys. The one that we just did was question 19. Now we are in question 20. In question 20, you have a log base 6, and you have your exponent is 4 over x times y. So the first thing I will do is I will apply the power rule. Sorry, I will apply the product rule, not the quotient rule. Quotient. Let's apply the quotient rule because they are dividing. I will subtract the two log to be the log, no, base 6 of 4. And then you have minus the log 6 of x minus the log 6 of y. And that is as far as we can go with this equation. No, there's nothing else I can do there to simplify that. So what we did is we applied to that the quotient rule. I'm claiming the rules because when we did the assignment of yesterday, that is from fall 25, I am giving to you all the rules. So you can go there, and I will try to put another document today that will have all in one sheet, all the rules. In order you can also use it. You can remember everything I place in Blackboard, you can download it and print it. So let's go to the next equation or the next example. 21, you have the log 5 of 25. Remember, every time that you have equal to something, a logarithmic expression, you have to equal to x, always. They said log of 5 of 25 equal, but they don't give you equal to what? You put the x. And then my next step is change this logarithmic expression from a logarithmic form to an exponential form. No, and when I do that, no, and it's base 2, so it's not base 5, base 2. It's base 2, log of 2 of 25. So if I do that, I will have 2 raised to the x power is equal to 25. All right, there is no a number that you can multiply. There is no a whole number that you can multiply as exponent that will give you a 25. So what we have to do there is we need to apply what is called the change of base. No, the change, and it's one of the rules that is in yesterday assignment in the fall 2025 PDF. No, change of base. Because there is no number that you can rise to 2 that will give you exactly 25. So what will happen is we have to change the base. And when you do that, you can pick any base for your number. No, it doesn't matter what base you use. But that will be equal, to the log. You can even keep log 2. No, let's change to base 10. No, log 10 of 25, no, divided by the log 10 of 2. No, and if let me change and let's try to go to a calculator. Let me use my pointer because I don't want to make a mess. So let's go to the Desmos calculator. Scientific calculator. And the way that I do there, you see, when you go to functions here, you have here the log. So I will put log, and because there's not a base, the system assumes that you are talking about the log of 10. Remember, when we don't have a base, the default base is 10. You put here, your 25, close parentheses. First of all, let me go back. The first thing that you have to do in the main is do a fraction. Now that you are in a fraction, you go to functions, and in the top, you put the log, you don't have to put, you pick log, let me pick log, and in the parentheses, you put the first one would be of 25, and then in the denominator, you put again log, and in parentheses, you have to put the 2. You are dividing the log of 25 by the log of 2. And the answer is 4.6438. That is the answer. Let me go back to my white screen. The answer of this equation will be 4.64385 618. But you need to see if they are asking to, in the assignment, they're asking you to round to 2 decimals. So if I need to round this answer to 2 decimals, I'll have a 4, and then I go to 64 and I look the number to the right of my 100 place. That will be 4. And when I look to the right, it's a 3. And because 3 is, is less than 5, then I round this down. I will take all these other decimals, and my answer will be 4.64 because they are asking for 2 decimals. If they're asking for 4 decimals, you will have to go to 38. And because 5 is great, 5 is always, the next number is 5 or greater, you will add 1 to the 8. So the answer will be 6439 if they're asking for 4 decimals. But in this assignment, they're asking only for 2 decimals. So we go until 64. So that is example number 21. Let me give you a minute, you copy your notes, and let's go to the following example. We're almost done. Again, I try to find all the examples that I found that will help you to do your assignment. Let me erase that. Let's example 22. Let's go to 22 of properties of logs. Because in the example 22, also you have another change of base. It's log verse 5, and you have 6.19, and you have your equal. Again, then if the log is not equal to anything, you should equal to x. And then you go from logarithmic form to exponential. That will be 5 to the x, 5 to the x, no, is equal, and you put the argument of the exponent, no, 6.19. And again, there's no number, there's no whole number that you can raise 5 that will give you 6.19. Because that, we need to do a change of bases. So you have to go here, no, you have to go to the log 10, no, of 6.19, no, divided by the log 10 of 5. And then you put this in your calculator as I did before, and the number that they will give you is 1.1, no, 326, 532, 532, and 528. And the system in this one, they are asking to keep 4 decimals. So my final answer is 1, and I go to my 4th place. No, my 4th place, that will be my 10,000 place. 1, 2, 3, 6. That is my 4th place or my 10,000 place. No, and I look the number that is to the right, and it's a 5. And because it's 5, every time that you have a number to the right that is 5 or greater than 5, you round up. That means I need to add 1 to the 6. And that will be 1, 3, 2, 7. And you drop the rest of the decimal. And that will be the answer for the example that we are doing right now. We're in 23. I lose the count, guys. No. But that will be the answer. So let's go to example 24. Example 24, we are using another property. No. In example 24, you have the log 8 of 2x minus 4. No, plus, no, the log 8 x plus 2. So what happens when you have a log that have the same base? Because these two logs have the same base. You can see both have the same base. No, both are the base to the base 8. No. When you do that, you need to apply it's called the equality rule. And the equality rule says that when you have the same base, you can say, no, that these two, let me, give me a second. Yeah, that is the one that we are using. No, this is the one. What they said is because you have the same base, no, you can say that these two are equal to one another. No, Or you can say that the sum of the two logarithms can be written as the product, no? Because both are base 8. Let me try to go through the whole thing. Oh, I missed something equal to 2. Sorry. So we can because both have the same base, we can write the the two logarithmic expressions as a multiplication of them, as a product of them. Again, the sum of two logarithms can be rewritten as the product of them. So in this case, you have 2x minus 4, no, times x plus 2, and that is equal to, remember, what we're doing is we are trying to write this in exponential form. The base is 8 and is equal to 2, so it would be equal to 8 to the 2, 8 to the second power. That is the equation now. We went from a logarithmic equation to a polynomial expression that you have to follow together. Because if we follow this together, we're going to start multiplying. 2x times x, you have 2x cubic, no? And then 2x plus 2, you have plus 4x. And then you have a negative 4 times x is minus 4x. And then negative 4 times positive 2 will be a negative 8. And that is equal to 64 because 8 to the 2 is 64. And what we'll do is these two guys cancel because these two are like terms but are opposite. It's positive 4x and negative 4x, they cancel out together. So you have now that 2x cubic minus 8 is equal to 64. So what we need to do now is, what we do is, I will subtract 64. I will subtract 64 for both sides. Let me erase the 23 because we are running out of board. No, oops, I erased the title, but that is part of the previous one. Yeah. So let me write this. What we need to do is make of this a trinomial. Because we will have, if we subtract 64 from both sides, now we have 2x cubic minus 8 minus 64 minus 64 equals 0. That's what we have. And if we do that, if we combine like terms, you have a 2x cubic and minus 8 and minus 64. You add together, but the answer is negative 72 equals 0. Now, my next step is I will then try to factor that. If I take a 2x out, I will have now in parentheses, I will have a x squared minus 72 equals 0. And Oh, sorry, not 72, it's 36, the half 36. And I have now is a difference to square. Just outside of my equation, I have a outside of my equation now I have 2x as one of the products, and the other product, is a difference to square. You do your parenthesis square root of x is x, square root of 36 is 6, one is plus, another is minus. And then what you have to do is you need to set all these to 0 to find the values of x. So you have 2x is equal to 0. You divide both sides by 2. You have that x is equal to 0, because 0 divided by 2 is 0. The next one, you have a x plus 6 is equal to 0. You subtract 6 from both sides, x is equal to -6. And then the third product is x minus 6 is equal to 0. And if you add 6 to both sides, that's a 6, x is equal to 6. So that is the answer. No, ahora, the point is, the first answer, we talk about logarithms, you can have the exponent of the logarithm have to be 0 or greater than 0. Because if you expand x to the 0 power is equal to 1. But you cannot have a negative exponent. So it's because that we have here you can, so let me go back. You cannot have a 0 as exponent because you cannot take the log of 0 or a negative number. So this one is cancelled, and this one is cancelled. And the only answer that you have for this one will be x is equal to 6. Again, the exponent has to be greater than 0 and has to be a positive number. When it's greater than 0, it's a positive number. No? And that is one of the rules for our logarithm. The exponent cannot be 0, no, and also it cannot be a negative number. So the answer for all these, number 24 will be x is equal to 6. Yeah, it was a little laborious, but we are applying everything that we learned before. We are applying factorization. We are applying the property of, we have applied the property of all the properties of logs. No, let me see. I think that was the last one. No, we have another one. We have another one. Let's do one more and we finish today. No, the 25. And we finish today. And again, all these are trying to resemble what you have in your homework. Then when you have, then you know what to do. The last one that we'll review today is the 25, and is the log of 22, no, of 22, and you have a x minus 4, no, plus the log of 22, and you have the x plus 5. I try to find another better way to explain that, but do you remember when we did For example, you have x to the fifth. You have a x to the fifth power, plus x to the seventh power. And what we did in this time, we put the x, and we multiplying them. You have a x to the x to the 5, and a x to the 7. And what we did is we put your same base and you add the exponent, and you have a x to the 12. Well, that is similar we're doing here, because the reason we did that, because the base, when you have a x to the 5, times a x to the 7, you have the same base. So what we did is, again, we add the exponent, and you have a x to the 12, and you solve for the number if you have a value for x. Well, here is the same, we have the same base, and because that, what we can do is, we in the other example, we were multiplying with the base and the exponent, and we add them. In this case, we are adding these two logs, because it's the same base, we can go and we can write this logarithmic equation as the product of these two exponents, and then you have to bring the base to the front, and that will be 22 to the 1. Now you know that every time that any number that is raised to the 1 power is the same one. So in reality, you have here 22 only. It's 22 to the 1, but that will be equal to x minus 4, x plus 5, and that will be equal to 22. So what we do now, I subtract 22 from both sides of the equation. No, first of all, I will FOIL that, and it's a x squared, plus 5x, and then you have minus 4x, minus 20 equal 22. And then you simplify like terms, the middle ones are like terms. You have a x squared, and you have plus 5x minus 4x will be plus x only, minus 20 is equal 20 is equal to 22. Then I will do is I subtract 22 from both sides. And when I do that, I have a x squared plus x, plus x, and then you have negative 20, negative 20, and there will be minus 42. 42, let me see, 20 and 42. 42. So we have a trinomial. We ended with a quadratic trinomial with leading coefficient, 1, because the leading coefficient is 1. Let me change colors. We have a quadratic trinomial, and the leading coefficient is 1. And when you have that, you can do the shortcut. But let's see if the shortcut work. First of all, we multiply negative 42 times 1. Negative 42 times 1, and you get a negative 42. So we need two numbers, that when you multiply them together, will give you 42, But when you subtract these two numbers or add, also will give you a 1. That is the condition. No, and the factors that we have 7 and 6. No, and it has to be a negative 42. So if we try 7 and 6, these two will be 42. And if we try positive 7 and negative 6, that will be positive 1. So if we can do the shortcut, let me put the parenthesis for the shortcut. Let me change colors. And then you have the square root of x squared is x. Let me do a better x. I don't know, this pencil sometimes. And then these two numbers could be plus 7 and negative 6. So it's 7 plus 7 times negative 6 is negative 42, and positive 7 minus 6 is 1. And we need to put both to 0 to find the answer of this equation. X 7 is equal to plus 7 equal to 0. You subtract 7 from both sides is equal to negative 7. And then you have x minus 6 is equal to 0. And when you add 6 to both sides, x is equal to 6. And we said already we cannot have as exponent because x is the exponent. So we cannot have an exponent a negative number because imagine that we replace right now 7. No, you have here the log, no, of 22, and here you have a negative 7 and a negative 4. That will be equal to the log 22 of negative 11. And we said we cannot have a negative exponent, no, or 0. The exponent has to be greater than 1. And because that, this 7 is disqualified, and the only answer that we have is 6. And you can see when you apply that, you have a log, no, you have a log of 22, no, and here you have 6 minus 4 plus log of 22, and you have a 6 plus 5, and that will give you the log of 22 of 2 plus the log of 22 of 11. No, and that is okay because are greater than 1. So the answer for this one is 6. And that is all I have for to you guys today, guys. We have worked a lot of logarithmic equations, and we try to use every one of the properties that we learn or rules in order to simplify them. And you are responsible for these assignments. And let me go quickly, let me go back to our, oh, I need to go to right here. And you can see we are doing property of law 6.5 today. Monday, we will work in log and exponential equations, and that is the last class for the exam number 4. That is the last subject that will be included in exam number 4. Then Wednesday and Friday, we'll still practice in 4 until we get to the week of this final, and then you will take your exam number 4. If you are an online student, you have a 5th exam. And the 5th exam, what we did is we tried to pick some subjects that were important for example, we put in the final exam 2 questions about polynomials, how to, what is a polynomial, what is the degree of polynomial. Then we put 4 questions of factoring, then 2 for rational expressions, 2 for root and radicals, one for linear, another one. It's 20 questions in total. But we try to pick, we were unable to put questions for everything, but we try to put questions of things that are very important because when you finish this class, you are going to probably chemistry, physics, and you will need these skills to work in these classes. Well, that is all I have for you today. I hope you are doing great and you enjoy this class and this topic of the properties of laws, and I enjoy it. And I will see you Monday again. Well, have a wonderful weekend. Bye bye.